Alright, time to continue the solutions for the vector transformations using matrices. So, in case you missed the last video, you didn't watch the last video, it does have a lot of explanation as to what I'm going to end up doing next. And mainly, if you have numbers down the main diagonal, you're just taking the first one times by the first thing, take the second one times by the second one, and you keep the order the same. If you have zeros down the main diagonal, you have numbers on the other one, you are going to switch the order of your components. Take this number, multiply by the old y, take that number, multiply by the old x, and that'll give you your new components. So back here at number 7, I'm going to do 4 times 9, which is 36. And then negative 3 times negative 4 gives me positive 12, and that's the vector. On 8, again, we need to switch the order, so that's going to be 2, 4, and we're going to take this times by that guy there, take this one times by the other one. You're going to get negative 6 and positive 12 for your result there. On 9, we have numbers down the main diagonal, so we're going to keep the order the same. First one times the first component, second one times the second component. We're going to get positive 30 and then positive 40. On 10, we zeros down the main diagonal, and so we're going to switch the order. And we have to take this first one times by that first one there, take the second one times by the second one, and that's going to give you positive 28 and then 7. And then on 11, we have numbers down the main diagonal, so we're going to keep the order the same. Negative 8 times the first number, negative 8 times the second one, you're going to get positive 16, and then 7 times the negative 8. It's going to give me negative 56. Gives that guy there. We have zeros down the main diagonal, so we're going to have to change the order. This number is times by the y component, that number times the x component. We're going to get 30 to start, and then 48 to end up there on this one. On 13, we have zeros down the main diagonal, so we're going to have to switch the order. We have to do 9 times the negative 9 there, and then negative 9 times the 5, which will give me negative 81, and then negative 45 for my vector. On 14, we have numbers down the main diagonal, which is great, so we don't have to change the order on my vector. You just take the first one times the x component, second one times the second component. You're going to get negative 6 and negative 5, which is a little bit different of a transformation. On 15, we have zeros down the main diagonal, so we're going to have to switch the order. And then this first one is get times by the second component there, and the second one times the first one. And that's going to give you positive 15. And then 6 times the 3 is going to be 18. Let me get this vector here. And on this next one, we have numbers down the main diagonal, so we'll keep the order the same how it is. Negative 3 times the negative 5, negative 4 times the 1 is going to give me positive 15, because negative times negative is positive, and then 1 times negative 4 gives me negative 4. There's my vector there. And next one, 17, we have zeros down the main diagonal, so we're going to have to change the order of our components here, so you're going to end up changing the order. 3 times the negative 3, negative 7 times the 2 is going to give me negative 9, and then negative 14. You see that? And then 18, we have numbers down the main diagonal, so we don't have to change the order. We have to do 4 times the negative 5 and negative 1 times the negative 1. It's going to be negative 20, comma, 1. And there's 18. Alright, and on this next section, you're going to have to write what the matrix would be in order to transform it from the starting vector to the transformed version of it. So these ones are writing our own matrix. And use the information that we've already gathered about the matrices and getting the transformation. So something to notice, here we started with 2, 8, and we end up with negative 8, 2. We had to change the order, so this first diagonal is going to be zeros. And this second one gets times by whatever's in this slot, and then the first thing gets times by whatever's in that top right slot. And so we went from positive 8 to negative 8, so it has to be negative 1. We went from positive 2 to positive 2. That gives us this guy here. and we don't have to write down what the transformation is, which is fine. We get this matrix here. And then on 20, we start out at 8, -9. We end up at -8, +9. So we didn't change order, so this diagonal is going to be zeros. We did change the sign on both of them, so we have to make both of these numbers in the main diagonal -1. So we can change the sign on that. And that matrix is complete. Moving on to 21, we have the same numbers in the same location, at least the same numerals in the same locations. We do have to change the sign on the first one, though. So +9 went to -9. So we need to put a -1 here, because that's what gets times by the x component. -1 stayed, -1, so we need 1 just to stay there. And then on 22, we started out with 2, a -2, -6. We end up with -12, -36. This is a dilation type, so you're trying to think of like one number that you multiply both by to get these results here, and that comes out to be just 6. So 6 down our main diagonal, 0 the other way, and then that'll dilate by a factor 6. And then bring us to the next column. Here again, we have some dilation going on of 8, -6, and we end up at 40, 30. Well, 8 times 5 is 40, and 6 times 5 is 30, and so we're going to have some 5s down our main diagonal, and 0s down the other way. But we didn't, this one's a little bit different, because it went from negative to positive, and so we have to change the sign on our lower right element of our matrix. And then brings us to 24. We start out at 3, 9. We end up at 27, -9. So this one's a little bit different. You don't have just one number you multiply by to get the next one. Well, there is one, but it's 9. But 9 times 9 doesn't give you -9. But if you could actually change the order to get 9, 3, and then multiply by 3 to get those numbers, or at least those quantities. So if we're going to change the order, we're going to do 0s down the main diagonal, and you have to do 9 times 3 to get 27, and 3 times -3 to get the -9 there. So that'd be my matrix. On 25, there was a typo on the printed version. Make sure you make the quick adjustment. That should be 3 instead of 8. Anyway, you start out at 3, 2, and you end up at -27, -18. That is multiplying by 9 on both numbers, specifically -9. And we didn't have to change the order, so just -9's down the main diagonal, 0's along the other way. And that brings us to our last matrix. So we have 2, -1. Well, if you take 2 and you times by 1, you get 2. But -1 times times 1 doesn't give me 4. But if I took 2 and times by 2, I'd get 4. And if I took -1 and times by 2, I'd get something really close to 2. And so I'm going to switch the order of these coordinates, of these components. And I'm going to take this -1 and times by -2 to get +2. That's going to be the first thing there. And I have to do 2 times 2, +2, to get the 4 there. So 2 is going to be the upper right. And that brings us to our last section here. So we have to state what the transformation is, what transformation is necessary to carry from one to the other. And so really this is a lot of referring to our old transformation functions. If you start out at 2, 8 and you change this order and you change the sign on the first one, that's going to be a 90-degree rotation. And more specifically, it's a 90-degree counterclockwise rotation. You can graph it out if you want to. On 28, we start out here. We're just changing the sign on both of them. If you change the sign on both your components, it's a 180-degree rotation, not rotation. Here we have 9, -1, -9, -1. So if you change the sign on just one of them, it's a reflection. And if you change the sign on the x component, it is a reflection over the y-axis. Things are just on the other side, laterally. And then on 30, we start out at -2, -6, to end up at -12, -36. We get times by 6, which is a dilation, so that's dilation. by a factor of 6. And that brings us to our last column here. And notice these are all like the same things as the ones up here. Hint, 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 hint. So right here, on this one we times the first one by, we times them both by 5, but we had to change the sign on the second one. So really this is 2 transformations. It's a dilation by a factor of 5, and we had to reflect over, and we had to reflect over the x-axis, because that'll change the signs on your y-values. So let's reflect over the x-axis. 32, we start out at 3, 9. We had to change the order and times by 3. So really, we're going to start out with a rotation. And this one had to be 90 degrees, because that's what you do when you change the order. And when you change the order and change the sign on the second one, that gives you a clockwise rotation. So that's the first transformation. And then we had to dilate by 3. That's a dilation by a factor of 3. 3. There we go. On 33, again, we have some dilation going on. But this time it's by a factor of negative 9. And that's it. It changes the signs for us. And dilation can do that. And that brings us to 34, which, again, we change the order and we times by 2. So you can think of it as a dilation by a factor of 2. And since you change the order and change the sign, that's a rotation, which is going to be 90 degrees. And let's see, if you change the order, change the sign on the second one, that's actually just like this one up here. It is a clockwise rotation. And there you go. There's the rest of them.